In section 4.2, homework problem number 33, we're going to graph the function f of t equals 2 times the tan of t. And in previous problems, we already learned how to graph tangent of t using the asymptotes, the zeros, and 1 point. So we'll repeat that process, but here with a 2 in front. So our a is 2. So that factor gives a vertical stretch to the tangent function we already know. So it's going to be a little skinnier, or not skinnier, but more stretched out, I guess. Okay, so our first step is to remember that tan of t is really the same as sine of t over cosine of t. And what that tells me is a couple things. Cosine of t cannot be 0 because it's in the denominator. So there is a vertical asymptote whenever cosine of t would equal 0. So thinking back to my unit circle, cosine of t is that x part of the unit circle. So cosine of t is 0 at pi over 2 and 3 pi over 2. Excuse me. And we're looking at this whole interval, so we're also going back one whole period. So that will also include negative pi over 2 and negative 3 pi over 2. And that's the 4 vertical asymptotes we have in that interval of negative pi to pi. So I can go ahead and draw those. So I'm going to scale my axis on this interval of negative 2 pi to 2 pi. So half of 2 pi gives me this guy, and then a fourth of 2 pi gives me pi over 2. And 3/2 pi. This is basically the quadrants of my unit circle. And I'm going up to negative 2 pi as well, so I just repeat that scale in the negative direction. And my y-axis, I'll use two little boxes for each unit so we can see the graph really well. Okay, now it's time to draw in those asymptotes that we found at negative 3 pi over 2, which is right about here. So there's one asymptote here. And then another one at negative pi over 2. So we have one here. And another one at positive pi over 2. And 3 pi over 2. And what I learned from the sine of just tan t is that the 0, it's going to be like a kind of like a swirly S shape, like that kind of shape with a 0 right in the middle. Not quite like that, actually. More like this, with a 0 right in the middle of those two asymptotes. So that looks like it'll be here and here, halfway between both asymptotes. And in fact, I can verify that because the same way we originally learned it, which is that we have a 0 when this thing equals 0. And that happens when sine of t equals 0. So thinking back to my unit circle, sine of t equals 0 when we are at, let's see, 0 and pi and 2 pi, and then extending that interval to go left as well, a whole cycle. that'll also go to negative pi and negative 2 pi. Now I don't really need to do this every time because I already know, once I have my asymptotes, I know the shape of tangent has a 0 halfway between all the asymptotes. But to verify it, since we're still learning, we can see that the zeros happen when the sine is equal to 0. So that's how I just kind of check those. Those are 0. Okay, and the last thing is to get that shape of tan. And that's where things are going to change here because we have this 2 is being stretched vertically by 2. So when we did just tangent of t, we found that at this halfway point between the 0 and the asymptote, we could do, like, for example, pi over 4 and negative pi over 4. At that point, on our unit circle, both sine and cosine are equal, right? That's our 45-45 triangle. So tangent of pi over 4 equals 1. So at pi over 4, I get 1. And in fact, the halfway point between the 0 and the asymptote on all of these is going to be 1. Except the fact that we have a 2 here in front now. So actually, I'm going to erase these ones. Whoops. And because I have a 2 out in front. So if that part is 1, then 2 times that is 2. So that amplitude of 2 changes that point of 1 to actually being up here at every interval. So it's the halfway point between the 0 and the asymptote is going to be the amplitude. In this graph, that is 2. And it's symmetric about that 0, so that also means I'm going to have a negative 2 halfway between the asymptote and the 0. So right there. But that's not negative 2, that's negative 1. There we go. And so now I have my curve that goes through that point negative 2, then through the 0, and then up. And it does that a couple times. Oops. And I have to go up to 2 pi because that's the interval I'm graphing, and then I can stop. And starting at negative 2 pi has 1 asymptote. So there is my graph of 2 tan t on the interval of negative 2 pi to 2 pi.